Hello folks, we come to the part 3 video of the miscellaneous exercise chapter 9, and let's take up this problem number 7, which says that there is f of x plus y a function which is given as fx into fy. F of x is 3 and summation of x taking values where x takes values from 1 to n is 120. In all this given thing, you have to find the value of f. Let's see how to go about doing it. They tell us that, no, this is not f of x, f of 1, I'm sorry, yeah. They give us that, given that f of 1 is 3. Let's consider what is f of 2, therefore f of 2. Can we call it as f of 1 plus 1? No problem, we can call it. But with what is given to us, it's clear to us that this can be written as f of 1 into f of 1. That's what is given, that if you have a sum, you can break it, the function like this, that's what is given. And f of 1 we know is 3 into 3, which is 9. So that means f of 2 is 3 squared. So that way we can develop the logic. f3 is 3 raised to 3 and so on. fn is going to be 3 raised to n. Also, what is the meaning of this? F of 1 plus f of 2 and so on, f of n is 120. That's given. We have all the values here, 3, 3 squared and so on. 3 raised to n is 120. Sorry. Sorry. Now this is a GP with A as 3 and R as 3. And we know in such cases the sum is given as A into R raised to n minus 1 by R minus 1. So let's have this sum here. It is 3 into 3 raised to n minus 1 by 3 minus 1, which is 2. How do we work it? 3 raised to n minus 1, let the 2 and 3 go on the other side. So how much is it coming? 80. 3 raised to n, when it goes there, is 81, which is also 3 raised to 4. Bases are same, you can compare the exponents and you'll come to n equal to 4. So our value works out as n equal to 4. We quickly go to the next question, the 8th one. It says that there is a GP whose first term is 5 and common ratio is 2. You have to find the last term and the n when the sum is given as 315. So, given that the sum is 315. So, by formula, it's A into R raised to n by minus 1 by R minus 1. A for us, it's 5. 2 raised to n minus 1 by 2 minus 1 is 315, which is 1 actually. So this can go on the other side, the 5. So it is 63. So 2 raised to n minus 1 is 63. The 1 can go on the other side, becomes plus 64, which is actually 2 raised to 6. Right? Bases are same. If you compare the exponents and n becomes 6. That gives us a last term, which is a plus n minus 1d. So sorry, that's for the AP. Now we are in a GP, so it's A R raised to n minus 1. A for us, it's 5. R for us, it's 2. And this is 5. So it's 32 into 5. Quick check. Yes. Then they tell us a GP where they give us a first term and they also give us a condition that the third and fifth term, it adds up to 90. So, this is AR squared plus AR raised to 4 equal to A is 1. So r squared plus r raised to 4 is 90. R squared common, r squared plus 1 is 90. Two ways of doing this. Actually, I would take it as a quadratic, solve it and find out the answer. Otherwise, another intelligent way of doing this is r squared and r squared plus 1. They are two consecutive numbers. Which is that consecutive number in 90 which could give you such a thing? Now, that's a different way of doing it. Writing this is like writing 9 into 10. Right? So that r squared gets equated to this. And of course the other one. Therefore, r squared is 9 where r is plus or minus 3. That's one way of doing it. Otherwise, you take it up as a quadratic, solve it and get the answer. So if that is the case, I don't know what they are asking us. They are asking us, find the common ratio of the GP. That's all. The required common ratio is plus or minus 3. Let's quickly take the 10th problem also. What does it say? The sum of three numbers of a GP is 56. The sum of three numbers is 56. And they say that, yes, this could be taken up in the next part of the video. I think that's enough, and then we could be taking it up in the next part of the video. Thank you.